All right, we're going to find the inverse of this function here, of a nice linear function. So I don't have to worry about any of that domain restriction stuff. These lines are kind of nice because they go on forever in both directions. And so when you think about this rule where the domain of one is the range of the other, it's not that big of a deal for lines. See, for lines like this thing, I already know before I start, the domain is all real numbers and the range is all real numbers. And so if you're interested in finding the domain or the range of the inverse, I mean, you would swap these two things, but it ends up being the same thing. So it's not that big of a deal. You don't have to overthink it when it comes to lines. So we can go ahead and start by swapping our x and y. All right, swap those. X is equal to 1/4 y plus 8. All right, I'm going to solve for y here. So I'm going to move my 8 over. I get x minus 8 is equal to 1/4 y. And then next, I need to cancel out this 1/4. So you could divide by 1/4 if you want to, but that's weird. No one does that. We're just going to multiply by 4. Okay, we'll multiply both sides by 4. All right, so I get, I could say this is my answer, but I think we should go ahead and distribute that 4 in. So it's going to be 4x minus 32 is equal to y. Or you could say y is equal to 4x minus 32. All right, let's check it real quick. Well, actually, let's just graph them. We'll graph it real quick. All right, y equals 1/4 x plus 8. Change my color here. And then my second function is y equals 4x minus 32. Zoom out a little, and you can see they are a reflection of each other. All right, if I wanted to plug in a number to actually check this thing out, if I plug in, say, 16 for x, I get a 12 back. All right, so if I plug in 16 for x, I get a 12 back. And then if I plug in a 12 for x on my inverse, I'm going to get a 16 back. Cool. The reflection of each other. And let's go ahead and check out this next one. So that wasn't too bad, the line. It's nothing crazy. You know what? Actually, I got a second. Let me do one that's got something where it's not so easy. Let's say it's y equals 3/2 x plus 6 to start off. No, we'll make it weird. 3/2 x plus 8. Yeah, 8. 8 should make it weird. So swap our x and our y. 3/2 y plus 8. And then we're going to solve this equation for the y. So we got to move the 8 over. I get x minus 8 is equal to 3/2 y. And then I got to get rid of this 3/2. So to get rid of the 3/2, what I need to do is multiply both sides by its reciprocal. So I'm going to multiply, reciprocal. I'm going to multiply by 2/3. Okay, and I got to multiply this side by 2/3 as well. So on the left side, I'm going to get 2/3 x minus, and then for 2/3 times 8, it basically comes down to 8 times 2 over 3. Like you could put this over 1 if you want to. So I'm going to get a 16 up top and a 3 down below. All right, and that would be my inverse function. Okay. Now let's look at another one of these square root ones where we've got to think through the domain and range, all that stuff. All right, swap our x and our y. 4 minus 2y. All right, so I'm going to solve for y. The square root part's already by itself, so I can square both sides. That's going to give me x squared is equal to 4 minus 2y. I need to move the 4 over and then divide by negative 2. So minus 4, I get x squared minus 4 is equal to negative 2y. And then divide by negative 2. Divide by negative 2. All right, so that comes out to be my answer. Y equals x squared minus 4, all of that stuff, over negative 2. Cool. Now, I need to figure out the domain part. So this is going to be one of those where I'll look at it on the graph first, kind of get a sense for it. So square root 4 minus 2x, that's my original. And then my inverse is x squared minus 4. All of that was over negative 2. It's kind of hard to tell, yeah, based on this, but it's always going to have something to do with this vertex, and you're going to ignore part of the graph. So I'm going to do curly braces here, and let's say I did x is greater than or equal to 0. That looks like that's going to work, yeah. If I had done x is less than 0, yeah, I do not get a reflection. There's no reflection going on there. All right. So the way you tell, again, what the domain is going to have to be, it has to do with the range of your original. So the range of this original purple one, it starts at 0. All right, that's the lowest it ever gets to, and then it goes upwards forever. So the range of the original is going to be the domain of your inverse. All right. So on my restrictions over here for my domain, I have to say x must be greater than or equal to 0.